Okay, so we carry on from this afternoon. I think most of you are still confused by this. Okay, so as explained, a general term is the algebraic equation, right, for a number pattern. So you can find the number in any placing along the number pattern. Okay, so n is actually the place value, the placing. Okay, placing. So it can be like first place, second place, third place, fourth place, fifth place, da 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 da. Okay, so what is the value of the number under that placing? Okay, so this is denoted by Tn. Okay, what's the place? So let's say the general term of sequence is Tn is 3 minus 3n minus 1. Okay, they want you to find the first four terms. Okay, so when n is 1, you just sub 1 inside, you get the answer. So the first number in the sequence is minus 4. Then the second number, when you sub in 2, okay, when you solve, you get minus 7. Then T3, as usual, you put in 3, you sub 3 into the equation, right? So I'm going to work it out here. T3 will be minus 3 times 3 minus 1. Alright. So from here, you get minus 9 minus 1 equals to minus 10, right? As written here. Then T4, minus 3, 4, minus 1. Minus 12 minus 1 minus 13. Okay? So that's how you get your number pattern. Right? You just submit the values of n into the equation and you will slowly get it one by one. Okay, so what if you need to find the 20th term? So the 20th term will be when you sub 20 inside, 3 times 20 minus 1 equals to minus 61. So now you try, what if your term is 2n plus 3? Okay, so you just submit slowly. First term, n is 1, so it's 2 plus 3, 5. Right? When n is 2, 7. N is 3, 9. N is 4, 11. So when you write it down, your number pattern will be 5, 7, 9, 11. Okay, so you realize it's also plus 2, plus 2, plus 2, plus 2. How about the 30th term? Just sub in n is 30. 2 times 30, you get 63. Okay, next one. Given that Tn equals to 2n minus 7, determine whether this number is a term. Okay, so this is more of a reverse. Okay, right? If let's say I give you a number, I say, is this part of the number pattern of this Tn? Right, so to find out if it's a number pattern, we equate first, then we solve for n. Alright, so 2n minus 7 equals to 2019. After you solve it, you realize you get n equals to 1013. So if it's a whole positive number, then yes, this 2019 is part of the number pattern for this general term. Okay, so how about 2020? Now when you solve 2020, you realize that you plus 7 on both sides, you get 2n minus 27. Then when you find n is 1013.5. So because it's not a whole number, so it is not part of the number pattern for this general term, right? So likewise, we do for Tn equals to 4n minus 1. Okay, determine whether each number is a term. Okay, so from here, what you will have is 83. Is it a term? So here I solved it already. We find out n is 21. So yes, n is a positive whole number, so it is a term. Okay, it is part of this term. Okay, so it's the 21st term actually. Yes, it is the 21st term. Okay, so it's 100 a term. Okay, so it's 100 a term, so 100, when you equate one, let's see, do I do it? Yeah, 1014, 104 plus, okay, let me do it clearer here. I think here is too messy. Okay, so is it a term? So you equate here, 4n minus 1 equals to 100, plus 1, plus 1. 4n equals to 101. So divide by 4 on both sides. You will get 25.25. Okay. Okay, okay, 25.25. So since it's not a positive whole number, it is not part of the number pattern for this general term 4n minus 1. Alright, okay, so pause the video here, try this on your own first. Okay, then when you have done, check your answer, then after that come and unpause the video to watch this. Okay, so this one for A, they ask you to find the first three terms. Okay, first three terms means T1, 5, 1 minus 2, 3. T2, 5, 2 minus 2. T3, 5, 3 minus 2. 15 minus 2 is 13. Okay, so you realize the difference between each number is 5. Alright, because the 5 keep multiplying with the increasing number of n. So part B, find T12. So very simple, 5, 12 minus 2. 60 minus 2, 58. Okay, alright. Then next one, A. We want to know, is 91 a term inside this number pattern for 3n plus 10? Okay, so to know if it's a number pattern, because this is the placing, right, you realize there is no, when you calculate, you will never get a decimal or fraction. It's always whole number. It must be whole number. Okay, so we need to prove when n is sub in, do we get a whole number? Okay, when you look at it, your value here and your n here, they're all whole numbers. Okay, so if I solve this, okay, A, 3n plus 10 equals to 91. Minus 10 minus 10. You get 3n equals to 81. Can I divide by 3? I can. Equals to 27. Okay. Is 91 the term? Yes. It is, as it is a positive whole number. Okay, so now it's 150 a term, so it's 3n plus 10 equals to 150. So minus 10 minus 10. So 3n equals to 140. Divide by 3. Okay, you get 46 and 2/3. 46 and 2/3. Okay, so no, it is not. As it is not a positive whole number. Okay, then the next one, number pattern from figures. Okay, so now we have figures that also form number pattern. So for example, we count the number of chopsticks here, matchsticks, sorry. So it is 4. 4, 1, 2, 3, 4, 5, 6, 7. 4, 7, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Then, so you realize this one, plus 3, plus 3. Plus 3. So this should be 12. So it's 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 plus 4. Sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Did I count it wrongly? Sorry, this should be 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah. Okay, so it's 10, then this should be 13. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay? Okay, so it's plus 3, plus 3, plus 3. Right? So from here, right, we learn to solve. So Tn is the number of matchsticks in figure n. So again, n is your placing. Right? This is the first picture, figure 1, 2, 3, 4, 5, 6. So n is figure what? N. Okay, so you have this one, each time add 3. So we know that our first term is 4, our difference is 3. So when we expand 4 plus 3 bracket n minus 1, okay, remember to expand this one. So you get 4 plus 3n minus 3, which is why you get 3n plus 1, because 4 minus 3. Which figure has 64 matchsticks? So this is the part where we have the value, we need to find n. Right, so we have this one. So 64 equals to 3n plus 1. So you minus 1, minus 1. So you get 63 equals to 3n, divide by 3, divide by 3, n equals to 21. Okay, so figure 21 has 64 matchsticks. Okay, now you have a row of triangles built with matchsticks. See below. Okay, let's see below. Yeah, look, row of matchsticks. So the first one is 3. Then you plus 2, so it's 5. Then it's 7. Okay. So based on this one, counts, add how much? 2 each time. What's my first term? 3. What's my difference? 2. So this is what? 3, 2. When you add together is 3 plus 2 n minus 1. 3 plus 2n minus 2. So 3 minus 2, 2n plus 1. Which figure has 71 matchsticks? We have our form here, 21 plus 1 equals to 71. Okay, minus 1, minus 1. 2n equals to 70. Divide by 2, divide by 2, n is 35. So n equals to 2n plus 1, n is 35. So figure 35 has 71 matchsticks. Okay, hopefully you can able to follow this quite easy. Okay, next one. The pattern below is formed with dots. Tn is the number of dots in figure n. 2, 6. Okay, so you started with 2. Then you plus 4. Okay, so 2 plus 4 plus 6. Right, 2 plus 4 plus 6. 2, 6, 4. Or, plus 6. Right, but down here is already 1, 2, 6, 6. So it's 12, right? So when you look at it, copy and paste, they tell you down here, given your general formula is n bracket n plus 1, find t5. So t5 is 5 bracket 5 plus 1. Okay, so this one is for this one. Okay, so if you look at it, 1 plus 1, 1. Okay, so 1 times 2, okay, equals to 2. Then when you have 2, it is 2 times 3. Okay, so an easier way to see this is not like this way. It will be more of rows. So 1 times 1. Alright, so let's say you have T1. It is 1, 1 plus 1. So 1 row times 2. The next one is T2. 2. 2 plus 1. Right, so it's 2 rows times 2 plus 1 is 3. Right. Then the next one is T3. 3 plus 1. Right, so down here 3 plus 1 times how many rows? 3. Okay, so quite simple when you look at it. You will just get the total number of dots here. So for T5 will be 5. 1, 2, 3, 4, 5. 5 rows of 5 dots each. So you get 5 times 6, 30. Okay, so which figure has 110 dots? So again, because we are trying to find the figure, we just equate n plus 1 equals to 110. Now, we can solve this if we try to solve this mathematically, it will be quite difficult, right? So what we're going to do, we're going to use reasoning. We need 2 consecutive numbers, n plus 1, right? So it means that the number should be like 7 times 8, or 8 times 9, or 3 times 4. What kind of numbers do we get become 110? Right? Because you all haven't learned quadratic factorization yet, okay, so it's okay. Right, from here, we know that we can separate it into 10 times 11. Right, so n is 10, n plus 1 is 11. right? So which figure has 110 dots? It is the 10th term. Okay, well, this question is good to know, but don't worry, it rarely comes up for exam. Okay, so let's go through this one again. Okay, so this one, if you count the number of dots, is 1, 4, 9, 16. Okay, so you realize there's something special. All these are 1 square, 1, 2 square, 4, 3 square, 9, 4 square, 16. Okay, so you want to find T7, right? So they already told you Tn is n square. So for part A, T7 is 7 square. So it's 49. Okay, so part B, which figure has 144 dots? Okay, so n square equals to 144. So square root to remove the square, n equals to 12. Use your calculator. Okay, so figure 12 has 144 dots. Okay, and then so we have this work example now. Okay, please give this a try. Alright, pause the video, give this a try, and then unpause it to see whether your answer is the same. Next two terms, okay, so I think it's quite easy. So it's plus 5, plus 5, plus 5. So the next two terms will be 27 and 32. First four terms of sequence are 2, 9, 16, 18. Express Tn. Okay, so first we find A. A will be 2. Then we find D. D will be 7. 7, 7. Okay, so Tn equals to 2 plus 7n minus 1. We multiply 7n minus 7. So we get 2 minus 7, 7n minus 5. Okay, then they want us to find T40. Alright, so after we find Tn, T40 is very easy to find. 740 minus 5. So we get 280 minus 5, we get 275. Alright, simple, quite easy, huh? Okay, next one. 95 a term is 200 a term. Okay, I think you know what to expect. Okay, but just do the working, show your working. Okay, 4n plus 3 equals to 95. So, first one, is 95 a term? Okay, so let's label this A, B, because the AI didn't do that. Okay, so minus 3 minus 3, 4n equals to 92. Okay, so divide by 4, n equals to 23. So is it a term? Yes, it is, as it is a positive. So a positive whole number. Okay, so part B is 200 a term. Again, 4n plus 3, 200. So minus 3 minus 3, 4n equals to 197. Divide by 4 on both sides. Equals to 4, 16, 37, 37, 9, 36. Okay, so no, it is not. It's not, as it is not a positive whole number. Okay. Next one, a matchsticks has 5, 8, 11 matchsticks. In figures 1, 2, and 3. Find Tn, which figure has 92, matchsticks. A matchsticks pattern has 5, 8, 11 in figures 1, 2, 3. Not too sure which one is he talking about. Okay, I think he's talking about his own one, right? So figure 1 is 5 matchsticks. Okay, figure 1. Then 8 for figure 2. Then 11 for figure 3. Okay, so is it in constant increase? Plus 3, plus 3. Okay, so find Tn. Okay, so we know our first one. A equals to 5. D equals to 3. So Tn is 5 plus 3n minus 1. 5 plus 3n minus 3. 3n plus 2. Now, which figure has 92 matchsticks? So we know our equation already. So part B, 3n plus 2 equals to 92. Minus 2, minus 2. 3n equals to 90, divided by 3, divided by 3, n equals to 30. Okay, can? Okay, next one. The general term is Tn n squared plus 1. Find the first 3 terms, then find T10. Okay, should be quite easy. So first 3 terms is what? 1 squared plus 1, 2. 2 squared plus 1, 5. 3 squared plus 1, 10. So T10 equals to 10 squared plus 1, 101. Okay, okay. So this concludes this topic. So go and try the app, the topic on the app, and then complete the supplementary worksheet. Okay, can? Okay.